Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on this concept of superpave mix design. So the superpave mix design procedure, it is considered as an improvement for producing a good performance asphaltic paving mix. So it is a short name for the superior performing asphalt pavement. It is an improved system for specifying asphalt binders and minerals, aggregates, designing asphalt mixtures and predicting the pavement performances. So here we can see the superpave mix design, the sample of the superpave mix design pavement. So the superpave mix design and analysis system uses 3 rigorous degrees of testing and analysis to produce a well-performing mixture for a given pavement project, which basically includes first, careful material selection and volumetric proportioning, second, intermediate mix testing and analysis in order to optimize the asphalt mixes based on the estimates of the pavement performance. Next, advanced mix testing and analysis in order to get better optimization of the asphalt mixes through sophisticated estimate of the pavement performances. Now, the objective of the mix design is to select and proportion the mixed materials to get an economical blend of paving mix and having certain desired properties over the service life of the pavement. These desired properties, they include first, sufficient strength to resist the traffic loadings without permanent deformation. Second, sufficient flexibility to resist the fatigue cracking. Then, the good workability in order to enable proper laydown and compaction of the pavement mix. Water resistive. Then, durability in order to have original good properties over the service life without unacceptable aging or water induced damages. And then, the enough surface friction properties to resist the skid of the vehicles. Next, in order to attain these desired properties, the asphalt mix composition, it should have sufficient quantity of asphalt binder to resist the adverse effect of water, but not high enough that will produce the weak strength. Then the sufficient voids in the mineral aggregates in order to have enough spaces, room for the asphalt in order to enable good aggregate coating and film thickness. So this is to get good durability. Next, suitable air voids content, enough air void content to allow for the further compaction, that is the densification due to the traffic, but not so high that it can result in the permanent deformation. Next, the levels of the superpave mix design. The design and analysis procedures to be used, it depends on the traffic level of the pavement projected. Level 1 is for the volumetric mix design for the low traffic pavements. Level 2 is for the volumetric mix design and intermediate performance prediction tests, and level 3 is the volumetric mix design and enhanced performance prediction tests. Now the volumetric mix design steps. First, the volumetric design, it consists of the 4 main steps. First is the material selection. Second, the selection of the design aggregate structures. Third, selection of the design asphalt binder content. And fourth is the evaluation of the moisture sensitivity of the mix. The non-destructive evaluation of the pavements. So the falling weight deflectometer, that is FWD, is a non-destructive pavement loading device capable of exerting a load impulse similar in magnitude and duration to moving truck and aircraft wheel loads. The falling weight deflectometer unit, it can produce loads from 1500 to 25,000 pound force. The load is applied to a loading plate by dropping a weight package on the damping system, and the signals from the load cell and the deflection sensors are then fed into the system processor, which selects the peak values and transfers this information on the onboard computer. Then a computerized system in the tow vehicle, it monitors and controls the testing vehicle. The typical test sequence is approximately 1 minute long. A testing produces very rapidly down a street, highway or the airfield. The deflection data as well as the pavement stationing and operator comments are stored on a floppy disk or analysis after uploading to the personal computer. So this is a falling weight deflectometer vehicle which is being used. The applications: rigid pavements locate areas of the poor support um, beneath the joint concrete pavements. Then determine load transfer across transverse and longitudinal joints. Estimate the subgrade and pavement layer elastic modulus values. Then develop cost-effective maintenance and rehabilitation alternatives. Flexible pavements to determine the structural adequacy of the pavement and identify causes of failure. Then to determine the uniformity of the support along a project and identify weak areas. Then to estimate subgrade and pavement layers elastic moduli values and to determine overlay thickness requirements. Then to develop cost effective maintenance and rehabilitation alternatives. So with this we shall stop. Thank you.